Hello, good day everybody. This is Orekoya Olusegun Physics Mathematics Fundamental on YouTube. Today we are taking a topic in mathematics. That topic is all about polynomial. Today we are going to discuss the concept of quotient, divisor, dividend, remainder, the factor theorem, remainder theorem, the evaluation of a given polynomial p of x as which x is equal to a. That is, given p of x, how do we get p of a? Then there are some exercises that I have here that we are going to solve. The first one says, given that f of x is this, we should evaluate f of 0, f of half. The second one says, simplify x cubed plus 5x squared minus 4x minus 20 divided by x minus 2. Then the third one says, sketch the graph of this polynomial function. Let's say f of x. We want to sketch the graph. Then the next question says, given these factors, x plus 1 and x minus 2, that of, let's say these factors now, they are the factors of this polynomial expression. But the value of p and q are unknown, and we need to get the value. Then after we have gotten the value, the question says we should factorize this function out completely. Now, we are starting. Let me say I have polynomial p of x is defined as quotient q of x times divisor, times divisor d of x, then plus the function of the remainder. This remainder that I have here may be a function of x or may be a constant. So I can have it in this manner, or I can also have polynomial p of x as the quotient of x times divisor function of x plus r, where r is a constant. So it's either I have my polynomial in this pattern or this pattern. The next thing I want to also indicate is that the function q of x is called quotient function in variable x. The function d of x is called divisor function in variable x. Then the function p of x, which is our polynomial, is known as dividend function in variable x. And then the function r of x that I have here is remainder function in variable x. And this particular r without variable x is called constant term. So what I have here now, I have this product of terms here, terms in q of x and terms in d of x, multiplying them together, combine to the terms in the remainder function of x. So this is the relationship. Now, if I divide, let me pick this first equation. If I divide both sides by this quotient function of x, I'm going to have p of x. When dividing with q of x, I'm going to have q of x. By the time I divide q of x with q of x, d of x will be left over. Okay, let me just show all my work. Q of x times d of x plus r of x. So I'm dividing through by my quotient function of x divided by q of x. So this quotient function cancels this quotient function. So what I'm going to have here now is p of x divided by q of x is equal to d of x plus r of x divided by q of x. So you can see now, this is the divisor multiplying this one. No, sorry, I'm supposed to divide through by the divisor. Sorry, I'm supposed to divide my function through by the divisor d of x. So I'm dividing through with this d of x, not q of x, because q of x is the quotient. So I have p of x divided by this divisor function of x is equal to q of x divided by divisor function of x plus plus r of x divided by divisor function of x. So that's what I'm supposed to have here. You divide through by the division function. So we have d of x divided by this, then divided by that. Now, if the divisor function d of x is x minus a, if it is x minus a, we can put this x minus a there throughout. So now, there is something I also want to introduce here. Like I said the other time, my polynomial function of x is given by divisor function of x times quotient function of x, then plus remainder or remainder function of x. If my divisor function of x is x minus a, then I will say times q of x plus remainder function of x is equal to p of x. Now, I want to introduce the idea of remainder theorem and the factor theorem. Now, this particular x minus a, which is my divisor function, is called factor of polynomial p of x. So now, at a point when the value of x is equal to a, that means anywhere I see x, I will put a there. So what I'm going to have here now will be p of a will now be x, a, because I put x as my a now, a minus a times q of a plus r of a. You know that a minus a will give us 0. 0 times everything will give us 0. So I have p of a is equal to r of a. That means if x minus a is a factor of this polynomial, then p function of that positive or the change in sign that I have here will give us the remainder. How do we do that? This is an example. That's the remainder theorem. Look at this. If I have, the question says, given this polynomial f of x is equal to x cubed plus 2x squared minus 3x plus 1, comma, find remainder when divided by x plus 2. Now, to find the remainder, you just set solution. To find the remainder, 4 of us set this x plus 2 to be equal to 0. So my x will be minus 2. So I'm going to take, anywhere I see x, I put minus 2. So I have f into bracket minus 2 is equal to minus 2 raised to power 3 plus 2 times minus 2 raised to power 2 minus 3 times minus 2 plus 1. So what I have here, I have odd power. When you are having negative sign and the power is odd, your result will be negative. So I'm going to have minus 2 raised to power 3 gives us 8. Here, the power here is even. So if I have negative here, if the power is even, my answer should be positive. So plus times plus will give us plus. 2 raised to power 2 is 4. 4 times 2 will give us 8. Then minus times minus plus. 3 times 2, 6 plus 1. Minus 8 plus 8 will give me 0. Then plus 6 plus 1 give me 7. So f of minus 2 is equal to 7, which is the remainder. So that means when this particular polynomial is divided by x plus 2, the remainder will be 7. That is the idea of a remainder theorem. But concerning factor theorem, if I put this function inside this expression, if my answer give me 0, then I have what is called the remainder theorem. Like for instance, let's say you are given this question now. You are given this question. Let's say you are given a particular question. Let's say this is a minus 6, and is x minus 2 a factor? If we just say, is this particular expression a factor of this? We can use the factor theorem or the remainder theorem to solve it. So set this x minus 2. Let's say x plus 2, sorry. Set this x plus 2. Set it to 0 here. So x will now be minus 2. So we are going to put this minus 2 anywhere we see x there. So we have f of minus 2 is equal to minus 2 raised to power 3 plus 2 brackets minus 2 raised to power 2, then minus 3 brackets minus 2 minus 6. So here, my answer here, minus 3 raised to power 3 gives us minus 8. Here, because of even the power, my answer here will be plus. 2 raised to power 2 is 4. 4 times 2 gives us plus 8. Minus times minus will give us plus. 3 times 2 will give us 6 minus 6. Can you see now? Minus 8 plus 8, 0. Minus 6 plus 6, 0. So we are getting 0. Therefore, x plus 2 is a factor of f of x is equal to what I have here. So I'm going to change my question here to minus 6 and see what will happen, so that we can be able to sketch the graph of it. Okay, so that is the idea of quotient, divisor, remainder, and dividend. So in my next video, we are going to solve this problem. See you in my next video. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Thank you for having me. Have a nice day. Bye.